Okay, in this last lesson, we're going to actually start touching on some things that you'll see quite a bit more in pre-algebra and in Algebra 1 as your math career progresses. Um, Coordinate planes, most of us have seen these before and have worked with these before. There's actually a lot to this that we can't really overlook, and you need to understand these terms. First of all, we have the coordinate plane in general is this intersection of two axes. We have the horizontal axis, the x-axis, and the vertical axis, the y-axis. We have the point of origin where the two meet is here in the middle at 0, 0. We have the four quadrants in your homework. You will see problems where it says to describe the location, and that doesn't mean anything like 3 and 4 or -2, 3. That means describe where it is in the quadrants. And as far as that goes, when you go to answer those questions in your homework, you guys, you can put things like Q1 if it's in this first quadrant on the top right. You can put Q1 or Q2, Q3, or Q4, and you should have some understanding about the numbers in those quadrants. For example, in quadrant 1, both the x and the y's are positive. In quadrant 2, the x's are now negative because we went this way, but the y's are positive because you're still above the or x-axis. Quadrant 3, both are negative, and in quadrant 4, x's are positive and y's are negative. So just by looking at a coordinate point, you guys should have enough understanding to know where it falls in the coordinate plane. The other thing we need to watch for is if it actually falls on an axis, say 5, 0, right here. If it falls on an axis and it's sitting right there, we don't say quadrant 1 and quadrant 4, we say it's on the x-axis. So have that understanding as well. This problem tells us to identify which ordered pair corresponds with point T, and then it has a bunch of points here in a coordinate plane. So really all we need to do is look at what the coordinate point of T is, and the book does a pretty good job of illustrating coordinate points here. The book says, okay, if I have a coordinate point and I start at the origin, I'm here at 0, 0, so I'm at the origin, and I go right 3 and then down 3. If I were to write that as a coordinate point, I would use the x value first, 3, and then the y value, -3. So if I look over here, I look for 3, -3, and that's C right there. Numbers 1 through 4 here are to write the coordinate point given by the following points in this table up above. So on your own, what I want you to do is look at where these points are and tell me what those coordinate points are on the graph up above. So, point P, if we look at point P, we start at the origin and we go left 3. So we go from the origin, we go left 3, and we go up 3. So P's coordinate point for number 1, P is going to be equal to -3 for the left 3, and then up 3 for the 3 from the x-axis up. Number 2, point Q. Q, if you look at it, if you start at the origin and you go left 2, you don't need to go up or down any because you're already at point Q. So all we need to put is -2, 0. Number 3, point R. We look at where we're at. We start at the origin, and again, we go left and right first. We need to go left 1 and then down 4. So we go -1 for the left 1, and then since we went down, we're going to say -4. Number 4, point S. Again, we start at the origin as always. We don't need to go left or right, but we need to go up 2. So since we didn't need to go left and right, we're going to put 0 for the x value and then 2 for the y value. In this one, it says plotting ordered pairs. Again, it's the same thing. It says to plot point A, we go -2, 3, and point B, we go 0, 3.5, -3.5, and it says to describe the location of each point. Here's where we're talking about using quadrants and axis and origin and those types of things. If you'll see here, again, if I look at the values, x is negative and y is positive. So I already know that it's going to fall in this quadrant right here. So the description for the quadrant, you don't even necessarily need to graph it to see that that's going to be in quadrant 2. This next one, it says start at the origin and you move 3.5 units down. Again, the reason we don't go left and right first is because 0 is our value for the x, so we don't need to go left or right, we just go straight down. Now, if we do not leave the y-axis, if we don't go left or right and we're still here on this y-axis, our location description is y-axis. So now what you guys are going to do on this one is, if you don't have graph paper, I have it over on the shelf. Go grab some graph paper, graph these points, put letters or numbers next to them so that you can label them in some way, shape, or form, and then describe the location. So make sure you put things like Q1 or x-axis or origin, whatever it happens to be. So number 5, we're going to go right 3 and down 1. There's number 5, and its location, I'll put it off to the side. Its location is quadrant 4. Number 6, we'll graph it, -5, 0. So again, we go left 5. 1, 2, 3, 4, 5. We're right here. This is number 6. Its location is x-axis. Number 7, -2.5. So I go left 2.5. That's right there. And then I need to go down 1. That's right here. And again, I already knew that since both of the coordinates were negative, that I was going to be in quadrant 3. Last one, we have -1.5, so I go left 1.5, that's right here, and then I go up 1/2, that's kind of in the middle there. So there's about where number 8 would be. Again, it's not perfect, but it doesn't need to be. Again, it's in the top left quadrant, so that's quadrant 2. Now on these, finding distances in a coordinate plane. It says an archaeologist divides an area using a coordinate plane in which each unit represents 1 meter. The corners of a secret chamber are shown in the graph. What are the dimensions of the secret chamber? So we look at this and they have the graph up on the top left of these dimensions, but now down here they actually have the picture of the box. In a story problem, what they'll do is they'll just give you these coordinate points, you guys, and all you'll do is plot the points and then connect them and then count. So what we have here are some dimensions. We have from +1 to +5. This side is 4 units. This side is 4 units. So again, those are meters. So we have what we want to do is we want to find the dimensions. So it's 4 wide, and if we start at -4 and we go to +2, this is 6 long. So the dimensions are 4 meters by 6 meters. Now it says in example 3, an archaeologist finds a gold coin at -1, 4. So if I were to go up here and plot this, I go left 1 and up 4, it's right there. And it says a silver coin at -4, 2. So -4, 2 is right here. And a pottery at -4, 4. So -4, up 4 right there. Now it says how much closer is the pottery to the silver coin than the gold coin. So it wants to know how close the gold coin at -1, 4 is to the silver coin at -4, 2. So what we do is just count these up. This one is 2 units away. This one is 3 units away. So you guys can just put that. The gold coin is 2 units away, and the silver coin is 2 units away.